All right, so hopefully you guys are well practiced now on taking the basic antiderivatives. Um, the ones we did in 13.1 are, those are the basic rules. They give us a foundation so we can do things that are a little bit more complicated, and that's what we're going to do today. So I'm going to pull up my note screen, and then here in a second when I get it ready, I will share it with you. Let's see, I need to add a new page. We did have class on Friday. It was just, it was a Friday and I didn't really want to do 13.2. Sorry. When I didn't have a lot of people in person or, in the meeting at the time we were doing it. So, basically just went over some examples. So I didn't record because we didn't really learn anything new. Sorry. Man, I don't know about you guys, but I am glad we did not have to go to campus today. I don't know, you might have to go later, but at least you don't have to go for this one because it is gross outside. So yeah, so I've got my note screen ready, so let me share that with you. Okay, so here we are. You guys, in 13.2, we are going to kind of talk about the chain rule, but in reverse, of course, because we are doing everything in reverse now. And we don't call it the chain rule, substitution. We call it U substitution when we go back the other way. Now, this is, it can be more complicated. We have to kind of make some decisions problem by problem, but there is a set method each time, with those decisions that you have to make as some of your steps. So the best thing to do is just to do a lot of practice. Kind of like the 13.1, you had quite a few homework problems, just so you could get used to going this direction. You'll have a lot of practice on this too. So I'm going to give you an example. If I wanted you to take the antiderivative of 4 times 4x plus 5 to the 5th dx. Now, when you look at this, it looks like chain rule, right? Because if it was the chain rule, I'd be like, oh yeah, I've got this 4x plus 5, it's to the 5th. And I would think about using the power rule around it, and then multiplying by the derivative of what's in there. We know how the chain rule works, but remember, that's not what we get to do. We have to go backwards. So I want you to think about this being the finished product of a chain rule. And we'll go from there. So think about when you do take the chain rule of a problem, you end up with the term in parentheses, but you also end up with the derivative of that term, stuck on the end, or sometimes we put it in the front. So when I see these antiderivatives today, I want to see two parts. I want to see the inside function. We're still going to be recognizing that like we did with the chain rule. We have to know what the inside function is, but we're also going to be able to locate the derivative of that function somewhere in my problem. So the way we're going to do it is with a method called U substitution. So let me tell you that when we have an antiderivative in this form, notice I've got the 4x plus 5 in parentheses, it's raised to a power. Just like you would pick that out for chain rule, we're going to pick it out again, but we're going to call it U. You guys, so today you always pick a U. So I say, okay, that 4x plus 5, being that inside function, I'm going to say that's U. And I'm going to say U equals 4x plus 5. Now, I'm also going to find a du, so a derivative of u, and we use du. You guys, the derivative of u, if this is u, 4x plus 5, what is the derivative of u? Isn't that just a 4? But you guys, we have this dx, and we're going to use it today. So notice I have du equals 4. You guys, I'm always going to put the dx in my derivative of u. Let me think of another way to say that so you can understand. Remember when we did implicit and we were doing a lot of dy dx, or we had the fraction? You guys, could I rewrite this here as du dx? So the derivative of u with respect to x is 4. Look what I did with the dx. I basically, if you multiplied that on both sides, you would get what we have here. We're just writing it like this. I mean, I guess you could always write it like this first and always multiply that dx on both sides, but it helps if you can just kind of skip that part and just put the du by itself over here, and you know the dx is going to stick on to whatever this derivative is. And it is important, though, that we have the dx. So you guys, what we've done so far is we've picked out a u, and I've said, okay, u must be the 4x plus 5. It's the thing in parentheses. If u is 4x plus 5, I found that du is 4 dx. And now what I'm going to do is I am going to rewrite my antiderivative, and not in x's, but in u instead. So watch closely. You guys, I said this 4x plus 5 is really just u, right? So I could rewrite this as u to the 5th. So do you see how 4x plus 5 to the 5th became u to the 5th? Now, when I rewrite, remember, I can't change it. I just have to rewrite it in a different way. So I've taken care of the u, and I've taken care of this 5th, and I wrote that here. So I'm done with this and this. But you guys, I still have a 4 and a dx over here that I need to rewrite into my new term with u's in it. But you guys, 4 dx, isn't that what I got for du? So you guys, what is this going to manifest as in the u term? You guys, that 4 dx is just the du part. So I can rewrite this as u to the 5th du. So make sure every piece is accounted for. Here is u to the 5th. I wrote that. Here is du. I wrote that. Now, why would I want to do this rewrite? You might wonder. Well, because we don't actually have a special form, to take the antiderivative of this as it's written. But do you think you could take the antiderivative of this? Isn't it a lot simpler? You guys, u to the 5th du, that's just a normal power rule. They are u's, but remember, it really doesn't matter. They could be x's, they could be t's, they could be y's. If you're taking the antiderivative of u to the 5th with respect to u, it's just basic power rule. So what is that? You guys, let's take the antiderivative. Let's remember power rule for antiderivatives. We have an x here usually, but in this case, since we're taking it with respect to u, we could sub that in with a u. But you guys, we take this power, and that's going to be n, right? So we need n plus 1, so that would be 6. And when we take the antiderivative, we're going to get 1 over 6, u to the 6th, and, of course, a plus c. Okay, so what I did was I turned it into a simple power rule problem so I could actually take the antiderivative, and I have 1 over 6 u to the 6 plus c. And you might wonder, is that my answer? Because I was taking the antiderivative of this term with x's in it and all these other numbers. Well, now you can just sub u back in with the 4x plus 5. You guys, so as a last step, you wouldn't leave it as u. Now you put back in what u equals. So I already said from the beginning that u was 4x plus 5. So this is going to be 1/6 times 4x plus 5 to the 6th plus c. So you guys, we have to find u and du. We have to do an intermediate problem by rewriting our original into terms of u. Take this easy antiderivative, and once I'm done taking the antiderivative, I just replace u with what I said it equaled over here. So I know that's a lot, and it is a lot, you guys, but we're going to keep doing it. So let's look at it again. These examples are easy to make up, so we can do this all day. You guys, what about this one? I've got 5x, and in here I have, let's make it, actually, let's just make it an x out here right now. So let's say I have an x out here. Sorry, I'm make it a 2x. I think I'm getting a little ahead of myself. I need this to be as simple as the one above. So you guys, what if I have a 2x out here? In here, I have x squared plus 3 to the 7th dx. And that's what I want to take the antiderivative of. So you guys, I don't, I don't care what's over here. Notice this time there's an x on the outside. When you're deciding what u should be, it is always just whatever's in this parentheses. So you guys, u in this case is going to be x squared plus 3. Du, you guys, what's the derivative of x squared plus 3? Well, that's 2x. And remember, with the notation I'm using, with the du dx notation, I just get to put my dx here with the 2x. Okay, so I have u and du. Let's look at our rewrite. So instead of writing x squared plus 3 to the 7th, because I've replaced that with a u, I can write it just as u to the 7th. Now, what about the 2x and the dx? Well, 2x dx, isn't that just du? So these two terms together are going to be rewritten as du. So I get u to the 7th du. So you see how everything just falls in line? When you rewrite this as a u, you have to have a du because that's the way we do antiderivatives, right? So there it is. It shows up for you in your problem. Wait, I am going to take the antiderivative here, so I don't need that sign anymore. Power rule, n is 7, so n plus 1 is 8. I'm going to get 1 over 8 u to the 8th plus c. And then remember, don't stop there though. You're going to replace u again with what it equals over here. So you're going to end up with 1 over 8 times x squared plus 3 to the 8th plus c. Now, you don't have to check your work on these each time, but if you want to, they're pretty easy to check. Remember, anytime you take an antiderivative, if you want to check to see if you got it right, just go backwards and see if you get to where we started. So you guys, what if I had started with the 1 over 8 x squared plus 3 to the 8th, and I want to take the derivative? Well, what would I do, you guys? Well, I would bring the 8 down in front, so I would have 8 times 1 over 8, x squared plus 3. I'd take a power away and get the 7th. And then because of chain rule, I would multiply this by the derivative of what's in the parentheses, and I would get that 2x. So do you see how we got back to where we started? Because that 8 times 1 8 just goes away, right? And so I have 2x times x squared plus 3 to the 7th. And that's what I started with. So you guys, don't let that confuse you. Remember, we're trying to get used to going backwards to taking antiderivatives. But if you do want to check, you would need to take the derivative of your answer and see if you could get back here. But I don't want you going, I want you to be able to go back and forth like that without getting too confused. I know it's like taking derivatives is a habit, right? And you might not want to do it too much right now. So you can kick that habit while we do antiderivatives, but it is a good way to check if you want to, if you feel confident in the fact that you can switch back and forth. So this is just a check. It's not part of the problem. We got our answer already right here. So let's do another one. So this one is going to be a little bit more difficult because sometimes they have a little extra, no, let's call it pizzazz. On this one, I have 5x plus 4 to the 6th dx. All right, so it looks pretty normal as we start. Guys, what would you do? You would find this in parentheses and call that u. So u equals 5x plus 4. But what about du? You guys, here's a habit that you might have picked up or you might pick up as you're working examples that you need to break. Notice in this problem, I'm moving up a little bit. Our u, we picked that out and it was x squared plus 3. My du was 2x, and that was present in my antiderivative. But you guys, sometimes people get in the habit of picking out u and then picking out du from your original problem. You guys, it worked before because, oh, 2x, that must be the du, and look, it is the du. But you guys, you can't find du always in your problem. Du always comes from actually taking the derivative of u. So look down here. I already picked out u, it's 5x plus 4, but there's nothing else. There's nothing else here. So you might say, oh, well, it's just the dx then, because that's all that's up there. No, that's not true either, though, is it? You guys always find du from u. Actually, take the derivative of u. Du here would be 5 dx. It's not always in your original problem. And when it's not, we do have to account for it, but we're going to take care of that. So you guys, du, even though there's not a 5 up here in the problem on the outside, du is 5 dx no matter how you look at it, because u was 5x plus 4. So when you do your rewrite, there's a problem. Remember, girls, we can't change the problem. We're just rewriting it. So I can see the u to the 6th part. But remember, I have to have a du here, but I don't have all of du present in this problem. I have the dx, but you guys, I don't have the 5. So you guys, if you wrote du here and just said, oh, it's fine, it'll work itself out, you're implying that there's a 5 in here when there's not, and you're changing the problem. So what can I do? Well, you guys, here's what we're going to do. I need a 5 in my original problem, and there's not one. So I am going to write a 5 in here. But remember, making a 5 in there changes the problem. How can I cancel it out is the question. Well, here's what we get to do. If I put a 5 into my problem because I need it as part of my antiderivative, I can put a 1 over 5 on the outside of the antiderivative, and it will cancel that 5 out. Because if I have a 1/5, now we haven't had to deal with it too much, but let's have a sidebar. If you have a number on the outside of your antiderivative, so like an easy situation like this, that number just gets multiplied by whatever your antiderivative is. So when I did this, I would just bring down the 3, and then I would do the antiderivative, and then these would just end up multiplying together. So you guys, anytime you have a number on the outside, it's just going to get multiplied by whatever your antiderivative is when you take it. You don't take the antiderivative of that because it's not part of that symbol, but it just comes along. It's basically a coefficient, right? So what I'm saying over here is that I'm going to do that. You guys, I need a 5 in here so I can rewrite this as u to the 6 du and have all my parts present. Because the 5 dx, that's the du part. But I can't just arbitrarily throw numbers into my antiderivative and expect them to come out the same, right? So I put a 5 in there, and on the outside, I put the reciprocal of that, the 1/5, because when I do multiply these two together, that's just 1, right? So I'm putting it in and canceling it out at the same time. And the reason I'm putting the 1/5 on the outside is because I don't need it inside. I only need the 5 inside, so I could have my complete du. Now, when I rewrite, though, that 1/5 that's on the outside has to come along with me. So the only reason the 1/5 is there is because the 5 was not present in the original problem. So I stuck it in, stuck a 1/5 on the outside, and it does come along when you rewrite. Because technically it's not really part of the rewrite. It doesn't have a u or an x in it. So it's just a coefficient that comes along. Now, if I want to take the antiderivative of this 1/5, well, I want to do 1/5 times the antiderivative of u to the 6 du. You guys, this 1/5, like I said, it just comes along. N is 6 here. So n plus 1 is 7. So I'm looking at 1/7 u to the 7th plus c. And you guys, what I get to do with these two fractions is just multiply them together. So let's call this 1/35 u to the 7th plus c. And as a last step, you replace u with the 5x plus 4. So I have 1/35 times 5x plus 4 to the 7th plus c. So it makes it a lot, well, not a lot harder, but definitely a little bit harder. You have to think a lot more when the entire du is not present from the beginning. And you guys, a lot of times it's not. We learn on the easy problems where it's just there. But if it's not, we just have to know how to put it in without changing the problem values. So let's look at another one. So let's say I want to take the antiderivative of x times x squared plus 7 to the, let's just cube it, dx. All right, so what are you going to do first? First step in all of these problems is to locate u. So u is going to be x squared plus 7. Remember, don't just say, oh, du just must be x dx. It might be, but remember, the way to find du is to take it from u. So if u is x squared plus 7, what is du? Well, it's actually 2x dx. So what do I have? I have x dx. What do I need? I need 2x dx. What am I going to do to fix it? You guys, I'm going to put the 2 in here because I need it there if I'm going to write this as u du. How am I going to cancel out the change that I've made? You guys, I'm going to put a 1/2 on the outside. It cancels out the 2, but the 2 this way is still present so I can use it. So when I do my rewrite, anything that I've put here on the outside comes along. Now, what's this going to look like? You guys, it's going to look like u cubed. And then the 2x and the dx, I rewrite that as du. And then I take my simple antiderivative, bringing that 1/2 down. N is 3 here. So n plus 1 would be 4. And I get 1/4 u to the 4th plus c. Multiply your two fractions together and get 1/8 u to the 4th plus c. And then replace u. So I get 1/8 times x squared plus 7 to the 4th plus c. I know this is a lot, but we are going to practice through it. So let's do another one. What if I have 2x plus 5 times x squared plus 5x to the 6th dx? You guys, this one looks more complicated. I've actually written it to where it's not as complicated. But what if you have, a bigger term out here? One thing you might say on this one is, well, how do I decide what's u? Well, u is the one in the parentheses that's taken to the power. So you know which one to pick between these two sets of parentheses. This one's being taken to the 6th power. That's going to be your u. So I'm going to say u is x squared plus 5x. And du, remember, take it from u, take the derivative of u, you'll get 2x plus 5 dx. So you guys, if you have multiple terms in your du, put them in parentheses with your dx here on the outside. Because again, if you had started with du over dx equals this 2x plus 5, you'd have to multiply both sides by dx, and you would have to, you'd have to make sure it distributed to both of those terms. So this is the easiest way to do it. So put your du terms in parentheses, and then you can put the dx on the outside. Now, what's nice about this one, I went a little easy because 2x plus 5 dx is already present in our problem. So I don't have to worry about adding something in or canceling it out on the outside. This is just a straight rewrite. So I'm going to have u to the 6th. And then remember, all of this, the 2x plus 5 and the dx, all of that is just equal to du. So it just gets rewritten as du. And how complicated did this look, you guys? And now I rewrite, and it's one of my just simple power rule antiderivatives. So n is 6, which means n plus 1 is 7. So I get 1 over 7 u to the 7th plus c. And then just replace u with the x squared plus 5x. So there we go. So you'll notice that on all of these problems, we've gone from two terms, like a product of two things. Like on this one, we had 2x, and then we had the x squared plus 7. We always get down to just one. Remember, because if we were doing the chain rule, if we were going in reverse, we would start with just the one thing, and we would end up with something on the outside. So you guys, you're going to be losing a term as you take these antiderivatives. So like on this one, we had these two terms. And then notice what we ended up with was just one x, one set of x terms, because we are going backwards. Let's see, let's do another one that's like that, but maybe we have to add something to it. All right, let me think. These are a little bit harder to make up on the fly, but I can do it. All right, so what if I have, let's do in here x squared plus 4x, and here I want x plus 2. Yep, that's what I want. All right, so you guys, I have x plus 2, and then I have the, I need to take the x squared plus 4x. Let's take that to the 5th power dx. All right, so what am I going to do? You guys, I have something in parentheses raised to a power. I'm going to take it out and call that u. And I'm going to say u is x squared plus 4x. You guys, I can't say, oh, x plus 2 must be the du, because it's not. You guys, what's du? Remember, it comes from the derivative of u. That would be 2x plus 4 dx, of course. So before I can rewrite, you guys, I have to put all of du into my original, right? But du is 2x plus 4, and I only have x plus 2. How can I get from x plus 2 to 2x plus 4? Well, if you look at du closely, could I write it like this? You guys, could I write that as 2 times x plus 2? Noticing that if I put a 2 into my original problem in front of that x plus 2, it does equal the 2x plus 4 I'm looking for. So you guys, sometimes like we have this binomial and we still have to add, or we have to multiply it somehow to make dx. And notice in this case, we multiply by 2 and it applies to this whole binomial and it ends up being 2x plus 4. So you guys, sometimes you're going to have to think about that. You might factor du a little bit so you can see that all you really need is just a 2 in the front. All right, so when we added this 2 here, it makes du complete. But remember, I can't just add a 2 in there, you guys. So I have to cancel it out if I put it in. So I put my 1/2 on the outside and that takes care of it. And you guys, it does come along. So I have 1/2, all of this in here. You guys, this is just u to the 5th. And then all of this here is just du. And then I take the antiderivative as normal. So I have 1/2. You guys, n is 5 here. So n plus 1 is 6. So I have 1/2 times 1/6 u to the 6th plus c. Multiply your fractions together, get 1/12. Let's go ahead and put u in as x squared plus 4x. Again, you can always go back and check because this seemed really difficult and then it ended up just being this. You might wonder if it really turned out like it should. You guys, if you do take the derivative of this right here, you would get the original problem. What about this one? Sometimes you have to really think about what goes on the in the front, you know, that canceling term. Like on this one, we had to put the 2 in, so we put the 1/2 in the front. What if I have 4 times 2x plus 9 to the 8th power dx? So you guys, what would u be in this case? Well, u would equal 2x plus 9. And du, you guys remember, take the derivative of u. Du is just 2 dx. But I have more than I need now. You guys, I need 2 dx, but I have 4 dx. What am I going to have to do here? You guys, I can't have too much or too little. So, how can I make this 4 into a 2? What if I multiplied by 1/2? Wouldn't that make it a 2? So you guys, if I have to multiply by 1/2 on the inside, what would I put on the outside? I would actually put a 2. You guys, it's always the reciprocal that cancels it out. So a lot of times you're multiplying by a whole number on the inside and then you flip it and it's a fraction on the outside. This one's backwards. You guys, I had too much. I had 4, but I only needed 2. So I put the 1/2 on the inside and the 2 on the outside. What's my rewrite look like? Well, it looks like there's a 2 on the outside. This 1/2 times 4, remember this is all just 2 dx. So that all is just du, and then it's u to the 8th. So I have u to the 8th du. And then I take the antiderivative, bringing the 2 down. You guys, n plus 1 is 9. So 2 times 1/9 u to the 9th plus c. Let's call that 2/9. Make sure you multiply that fraction correctly, since that 2 would be on top this time. So I have 2/9, and then in here, 2x plus 9 to the 9th plus c. So I promise this gets familiar as you practice it. You'll get better at it. Identifying u and then making sure you always find du from u. And then knowing how to, woo, that was loud. Okay, so, and then knowing how to account when you don't have all of du, or maybe you have more than you need for du, how to account putting something on the inside and outside. You know, you get used to that and it does get easier. On the next couple examples though, remember that chain rule didn't only apply to binomials being raised to powers. Didn't we also apply the chain rule when we were doing things like exponential functions? And you guys, we absolutely did, which means we absolutely have to go backwards. And it's not very different, you guys. It might even be a little bit easier. Let me find one. All right, so let's do this one. I have 6x squared. So I want to take the antiderivative of 6x squared times e to the x cubed dx. Now, the thing that you really need to understand the most when you have the e's is what to call u. So up here, it was really simple. Oh, whatever is being in this parenthesis raised to the power, that's always u. It's easy to pick out. You guys, when you have an e in your problem, u is always the exponent on e. So it looks different, you guys. It's a different form, and we're picking out a different value for u than we were. But if you have an e, u is always the power of e, always. And it's the whole thing, whatever that power is. So you guys, don't get ahead of yourself. So when you see a problem like this and you see the 6x squared and the e to the x cubed, you might think, oh, this is a product. I need to use some kind of product rule. You guys, and then you start maybe finding like the u and v, and you start going back to the derivatives. You guys, there's not a product rule for integration. Just FYI, you guys, when you see this, if it's more complicated than just a basic antiderivative, it's going to be a u substitution. So you guys, because I look at this, I know it's got to be a u substitution, and u is always the power on e. It must mean that u is x cubed. Well, if u is x cubed, what is du? Well, it's 3x squared dx. Okay, so you guys, the rewrite is similar. I have to have u in my rewrite, and I have to have du. The idea behind the rewrite is the same. Everything over here has to be accounted for over here, and vice versa. Now, notice that du is 3x squared dx, and what I have is 6x squared dx. What do you think I'm going to do to this 6 when it needs to be a 3? This all works the same way, guys. Multiply it by 1/2 on the inside, which means what do I need on the outside? A 2. So in my rewrite, that 2 is here. Now let's see if everything's accounted for here. Now, think about it. Your u rewrite's not going to be in the same form. It's not going to be u raised to some power, is it? No, because u is the exponent on e. I haven't replaced this e with anything, and it's going to be part of my antiderivative. When you have an exponential function, your rewrite is always going to look like e to the u du. So different form because it started from a different type of function. So you guys, the e to the u, you can see that because u was the x cubed. So I get the e to the u. Now the du is taken care of by this 1/2 times 6x squared, which is 3x squared, and then the dx. That 2 on the outside is balancing out that 1/2 I had to put in. So from here, what do? Once you make the rewrite, what do? You take the antiderivative. You guys, I'm going to bring this 2 down. What's the antiderivative of e to the u? Well, remember, this is like just saying e to the x. There's nothing special going on. It's just the basic exponential function. The antiderivative is just e to the u. Then you have plus c. That looks kind of like an a. Let me fix it. So you guys, this rewrite is always the easiest antiderivative to take because you always rewrite it as just e to the u. It never gets more complicated. You always just bring down that same e to the u. The only thing that changes is possibly what's on the outside here. So I get 2e to the u plus c. What's my last step? Well, I'm going to replace the u with the x cubed that it started with. But you guys, all of this, 6x squared times e to the x cubed dx turned into just 2 times e to the x cubed plus c. We haven't checked. Let's check this one just to confirm that it worked because this is our first exponential problem. You guys, well, let's check. How do I check? I start with the answer, take the derivative of the answer. So if I was taking the derivative of this, well, the 2 would come along. And what else would happen, you guys? The exponential term always comes over as is, but I would do the chain rule here and get a 3x squared. Oh, it looks exactly like what I started with. So you guys, it's all there. It's just we use u to make it easier on ourselves so we can actually take the antiderivative. And you guys, one more example. What about a natural log? You guys, there are times when we're going to have to do a u substitution, and what we have is really a natural log problem. Now, you're not going to see the natural log until the end. Remember, because when you have an antiderivative, it would start as 1 over x, and then you take the antiderivative and it equals a natural log. So let me give you an example of a problem that when you look at it, you're going to know it's a natural log problem. Here's what I have. It's going to be a fraction. You guys, you don't have very many fractions happen in u substitution. If they do, there's a good chance it's going to actually be a natural log problem. Now, how do I know that this is a natural log problem? How do I know I'm not just going to find, you know, a u and a du just like the normal ones that I did above? Well, again, it's a fraction. And notice the thing that's on the bottom here is just to the first power. Remember, that was a telltale sign of a natural log problem in the basic version. Remember, if I had the antiderivative of 1 over x, and it was just x to the first down here, I knew that was natural log and not power rule. So this is going to end up being a natural log when I take the antiderivative. But if I had like 1 over x squared, that was just power rule, right? It's only when it's the first power on the bottom. Now, don't let this squared fool you. You say, oh, there's an x squared down there. This is just power rule. No, because that's not how these things are working. You guys, this term is, you have to consider the whole term, and it is only being raised to the first power. So when I see this in this particular form, I don't even care what's up here. That will work itself out. But you guys, I have a term down here raised to the first power. This is going to end up being a natural log. And when I do that, I consider that when I make my decisions. Now, your u is always going to be the thing here in the bottom parentheses. Easy to find, you guys. Just you don't have to worry, oh, is it top or bottom? Where is u? U's from the bottom. It's the thing that was being raised to the first power down here. So if this is u, what's du? Well, it would be 2x plus 3 dx, of course. And you guys, I think I have everything present. You guys notice, here's du, and here's u, or the dx is part of du. So here's du, and here's u. So you can rewrite this as, you can rewrite it in a couple ways, actually. You could write it as du over u, because that's exactly what it looks like here. The way I like to see it is, remember, you can separate these two and call it 1 over u du. That looks more familiar to me as far as taking the antiderivative, but either way, this says the same thing. I had the complete and exact du term in my problem already. And notice that this dx would go on top if you had to put it somewhere. So you can see that this would be like du over u, but if you want to separate it, if it looks more familiar separated, you can write this as 1 over u du. Now, how do I integrate 1 over u du? Well, this natural log, right? So remember this 1 over x, like on this problem here, if you had 1 over x dx, what would you do? Well, you would do, oh, that's just natural log. Don't forget absolute values. And you'd get the natural log of the absolute value of x plus c. Whatever's down here goes here. Okay, so I can do that. So I've got 1 over u du. That's going to be the natural log of the absolute value of u plus c. And it is that simple. You're going to take the most basic natural log antiderivative. And then at the end, what are you going to do? You're going to put in x squared plus 3x where there's a u. So you put the x's back in. So just as a recap, you've got stuff raised to a power. This is a u sub. And it's going to turn into u raised to a power du. So you know what you're looking for as far as the form goes when you rewrite. If you have e raised to whatever, some stuff, I don't know how you want to notate that, but you have e raised to something. You can make it a question mark if you want. It's going to become a u sub, and your rewrite is going to look like e to the u du. If you have something up here, so something up here over something down here, and this something down here is to the first power. I know these squiggly lines are super informative. But if it is written in this way, where you have something on top, I don't care what's on top, but on the bottom you have something raised to the first power, it's going to be a u sub with the form 1 over u du. You guys, these are your three choices, and you have to make the choice. You know, and then you pick out u, then you do the rewrite. You guys, on this one, notice that your du was all present, but if it wasn't, it would still work the same way, where you might have to put something out here and something on the outside to cancel it out if you needed to. So it all works the same way. All of these work the same way. It's just how you start them and what your rewrite looks like. So I know that, again, I keep saying it, I know this is a lot because it is. You guys, u substitution is not an easy integration technique, but once you practice it, it might be kind of easy. You know, if you practice it enough. I mean, I've done it so many times I could do it in my sleep, right? And I'm not saying you need to get to that point, but it does require work. So you'll be seeing this homework here in a little bit. I'll be opening that up. And that'll be, you know, due on Sunday. We don't have anything huge coming up this week or anything, just normal homeworks. So just get working on that as soon as you see it come up. It'll probably be not like right now, but probably after my next class. And I will just see you guys here on Wednesday.